Hey, welcome to Not Your Mama's Rockets for an engine test. This is the 4.25 with inch with a new potassium nitrate. Got a light. And notice it was a immediate power, and it'll be showed on the graph as we work through the computer part of this slow version of it with the sound not synced with the picture, obviously. Okay, we're going to take that information off the load cell and put it into a spreadsheet and generate an engine file on it. And so we will connect to the load cell with using PuTTY. PuTTY is a free program for Telnet, and I'm going to change the IP address to what the device is telling me its IP is, port number 8888. And we will do on the sessions where you're going to save it and to record everything. And we tell it to open it, and it's telling me that the file is already there. Do I want to overwrite it or append it? And you just say yes. And now the engine data is in PuTTY. It is not written to the file until you close this window. So we're going to close this window, which will write the file. And that's the time that the file was, PuTTY was connected and generated this report. The other time is the time that the engine actually was tested. All right, so we're going to close this, and it says you want to replace it, and it's yes. Are you sure you want to close it? Is what it said. Then we open Notepad, and we're going to go open that file that PuTTY just wrote. And you tell it where you want it to be saved. Mine is saved at PuTTY Old Stand and the date it was recorded. And you open that. Now in Notepad you have the engine data, the PuTTY log, time and date, the time of the test. It was generated by the load cell device. And then the time slots and the max thrust during the test. It just picks out the biggest number and records it there. So once you're happy with that, then you select all the data. Or maybe you just wander around with a mouse and somebody tells us what to do. Okay, so we're going to open the spreadsheet called template. I'll say mine is template. That's just a blank spreadsheet with all of the functions built into it. And then we're going to paste that data at cell number A1. It has to be at A1 so it picks up everything in the correct order. Select all, copy. And now we're going to paste it. It was already in there is what the problem was. I want to show you where to put it. You put it in A1 and then paste. Now the spreadsheet has the engine data in its file. And the time is column B, column C is in grams, D is in pounds, E is in newtons, and I is going to be the 5% burn graph and data. There's already one value there, but it's just to show you where to put it. So you look at the 5% max is 8.46. That is the max, the entire 5% burn, and that is the 5%. So we want everything greater than that number and, well, greater than all the way from the start to the end. The beginning is greater than 8.46, and the ending is at where it drops to 8.46. And it's called a 5% graph, or 5% data set. And we're going to copy newtons. So we're going to scroll down and find 8.46 or something greater, which was 32.29. And we're going to go down to where it still stays greater than 8.46, which 8.63 is the last data. And we're going to copy that, and we're going to go back up to the 5%, the orange column, and we're going to right click. And we can't paste the functions, we're going to paste the data. All right, now we have the 5%. And so once it's pasted, then now you see that the burn time total was 1.8. For the 5% is 1.37. The time slot's 0.02 seconds. And the letter total of the engine designator is 119.47. And if you look over at the right where it says class 80 to 160 is a class G engine. So it is a G. And we come down to the average thrust, which is the number section, and it's 86. So it's going to be a G86. And you can see the max thrust in newtons, the propellant weight, the weight in kilograms. And so now what we're doing here is a G engine, a full G is 160 newtons. So we put that in there, and then down below where it's got G86, you will see this engine is 75% of a full G engine. And then below propellant weight is the specific impulse of the engine. The higher the number, the quicker it's converting fuel into thrust, the more efficient the engine is. So now we're going to go down and look at the 5% graph, and you can see that it's a very good power curve. It's going to kick it off the launch rod and then drop back down to 0. It looks compressed because the graph is doing the entire 1,000 data set, and we're only using the first 100 or so. So all that flat line is just nothing. And over to the right is some notes. This probably don't pertain to this graph. It just was already there. And what I'm going to do now is go expand this graph out where you can see the engine results in great detail. And we're just going to change, instead of where it does the full thing, we're going to change it to where it's just pertinent data. And I didn't quite get it that time. I think it ended at 73, but I'm having to go back and look. Then we go through the same thing, select the data, and then go to edit the data, select newtons, and then edit. And what you want to do is change where the end is. I think it looks like 200 there now. And it will change it to like 75, I believe. And say OK. And that's the same graph. It's just zoomed in. It's a graph of the engine data by itself without that long dead end to it. I don't always do that. I just look at it the way it's done and can pretty much tell what I want to see. And you can see how fast the power came up on it. And here is just a raw grams data for the entire engine burn. And you can see that from light to peak is just almost 90 degrees. That is really good to see an engine graph do that. And this last one is the engine data. It just takes the newtons and converts it back to pounds and gives the time. And this information you can copy and paste into the thrust program, and that will give you a .engine file to use in Open Rocket. So we're going to copy that, put it in Notepad. And then we're going to save that into the thrust programs directory. And we'll just call it a e86.txt. Thrust program. And the E86, I believe, is already there. G86, I don't know why I'm saying E. G86. It's already there, so we're not going to rewrite it, I don't think. And I guess we are. Now we're going to run the thrust program. And we're going to tell it to open at G86. And it's going to do its own calculations, which comes out to a G86, but it thinks it's a 48% of a G with the same thrust curve. And then we put in the information. I used millimeters lengths, and delay would be 0. Propellant weight, we're going to change over to metric and put in 139 grams. And a total gram weight of 313 or so. And I use DEX for my engine files so I can find them easily. Then we're going to copy that engine file and put it into we're going to put it into Open Rocket's engine thrust. That's where it picks up the non-manufactured or homemade engines is out of this directory here. We're not going to write it again because it's already there. And each time you put a new engine in this directory, you have to restart Open Rockets before it will pick it up. And now this is the 3-inch that we're going to test that motor on. And it's a 1.56 caliber stability. And if we go to the flight, we have the G86 in there. I believe we do. So then we're going to go get the flight characteristics. Flight simulations, and you can see at the bottom the G86 is coming off the rod, 8-foot rod at a very decent foot per second. The apogee is 974, and the rest of the information is not really useful for what I'm trying to do. I'm using Bandicamp to record the PC. So that ends it for this video. We took the engine, tested it, ran it through, created an engine file, downloaded off the device using PuTTY, and then made an engine file. Well, that wraps it up for this video. Hope you enjoyed it. Hope you learned something. Thank you for watching, and see you later.